Okay, we're going to talk a little bit about interpreting linear regression lines. We're going to talk about what the rate of change means, what the initial value, and what interpolations and extrapolations. Interpolations and extrapolations. I can't say that word hardly today. Extrapolations, how to get those values. Okay? Well, when we're looking at, say, data, all right, and in this problem here, it gives us our chart where we have our height and our weight, and it actually gives us an equation of a line. Y equals 53.7x minus 156, okay? It's going to give us that data. And what it's saying is, okay, hey, what is the rate of change? Well, the rate of change, or slope, is the rate of change when we're looking at the equation of a line. And when we're interpreting that in real life, don't say, oh, it's rise over run, which that is what slope is, but that's not what they're wanting you to interpret it as. They're wanting you to interpret this as a rate of change. And what does a rate of change mean? It means I'm changing my y's. It's the change in y's over the change in x's, but in real life. Well, what are my y's? In this case, it's weight, which is pounds. Okay, and that line here is per. And then what is my change in x's? My x's are measured in the height, which is in pounds per foot. Okay, so what is it saying? Well, it's positive, so it's going up, and 53.7 pounds per foot. That's how you interpret the rate of change or slope when we're dealing with a regression line. So when we're looking at it, we look at this slope and we look at our units along the y-axis per 1 unit along the x-axis. And I understand slope is rise over run, but that's the way we want to look at it or interpret it when we're talking about real life situations. Now, the second thing that we talk about a lot of time is what's called the initial value. Well, what's the initial value? In this case, the initial value is always your y-intercept. In this case, it's a negative 56. Well, what does that mean? Well, in this, it doesn't make much sense, but that is the starting point for this equation. So a negative 56, and it's crossing the y-axis, it'd be a negative 56 pounds is where this is actually starting. Well, can people weigh a negative 56? No. So it doesn't really make that much sense in context of this problem. But what happens, let's just assume that had been a positive 156. Well, what would that have meant then? It would have meant that the starting at 0, we started at 156 pounds. So sometimes, especially if that's a positive value or if it's in the inside of my data, if it's a good number, then we can interpret it as a starting value or an initial starting point for this graph or for my information. When I'm talking about, so anytime you're talking about, it says explain what the slope means, explain what the intercept means. Slope, they want it as a rate of change, which means it's the change in the y's, pounds, over the change in the x's, which is measured in feet. So we would say pounds per, because that means divide, pounds per foot. And then the initial value, or the intercept, is always your starting value, your initial value, where you would start your data off. On this one, again, if I'm looking at this and it says interpret the slope, it's a negative 3,587. So what does that mean? I'm going down marriages or marriage license per year. So marriages license per year. The negative means it's going down. So you're going down 3,587 marriage licenses every year. We're losing that many marriage licenses every year. Well, what year did it start with? In this case, if it's 2000, each bar looks like it is 2. So starting at 2002, starting right here, which would be 1998, 2000, 2002, 2004, so this would be 1998. We started with, what, 7,318,800 marriage license. That would be my initial value right there. So that's what the initial value actually would have been in 1998. So remember, this is the slope is what we call the rate of change, and we have to look at it as the change in y's over the change in x's, but in word form when we're interpreting. And this intercept right here is the initial value. Well, it would start right there. What would that value be? Now, when we're looking at it again, remember our correlation coefficient. You know, if it is sort of scattered, it's not as good as if it is a straight line. The straighter it is to a line, the closer it is to a 1 or a -1. The more scattered it is, the more random it is, the closer the correlation coefficient is to 0. If there is no correlation, a lot of times, you know, we can't make predictions. There's 2 ways to make a prediction. We can either what's called an interpolation, which an interpolation is when I'm dealing with a data point. I want you to estimate a value. So maybe I want you to tell me what it's going to be in 2002. I want to figure out how many marriage licenses there would be in 2002. Well, 2002 is within the 2000 to 2014 data, my lowest to my greatest. So that would be an interpolation, and I would just stick it in to my equation, 2002 plus 7318800, and I would crank that number line. Now, an extrapolation, I might say 2020. It's outside of these values between 2000 and 2014, so it's outside my data that I have retrieved. So that's what an extrapolation is. Now, I would find it exactly the same way. I would plug it in here and I would crank a number. But I would have to understand that this extrapolation is if the data continues thusly. And sometimes it may get down here into a negative and it won't even work, okay? So we have to assume that in extrapolation, the trend has to stay consistent. It can't start veering off or making a U or changing. We're going to have to assume that the conditions always remain the same. Everything is going to stay exactly the way it was between these 2 values. In interpolation, we're pretty good. That is pretty much for sure what it would have been. It's a much better guesstimate for your data than an extrapolation. I hope this helped. We'll talk to you later. Have a wonderful, wonderful day.